Okay, this is term 3, week 4, chemistry. Okay, question 1. It's mostly easy. Heat content. Hess's law might be a bit complicated, a bit tricky for some people. With time you'll understand. Which of the following refers to the heat content? I mean, it's obviously H. Heat, H. Delta H would be the change in heat. Okay, that could come. Delta H means yani, this delta H. This means change in heat or enthalpy change. That could come. Okay, which of the following are endothermic processes? Endothermic, remember, means putting in energy. Okay, putting in energy, right? It absorbs energy. Okay, let's start with melting an ice cube. Okay, I'm gonna draw it for you like this: solid to liquid to gas. As you move to the right, it's endo, because the matter has to absorb energy to change states. If you remember from physics, it was, remember, it absorbs thermal energy and kinetic energy to change states. So that's why whenever you're melting, okay, you're going from a solid, you need to absorb energy to break the bonds between this ice cube to make it a liquid. So that's endo. B. Heating carbon with water vapor to form hydrogen gas. Okay, you'd probably say, طب, Walid, if there's heat, isn't it exothermic? Okay, no, they're not saying it's released heat. We're saying we're heating carbon. So that means we're applying heat energy to the carbon so that this reaction can occur. So since we're inputting energy, we're absorbing this heat energy for the reaction to occur. That means we're putting in energy. That means it's also endothermic. Cooling water vapor, obviously, if you're cooling water vapor, again, some people will see the word cool and they say, oh, that means it's endothermic. No. Okay, water vapor, okay, whenever you go to the left, that's always exothermic. Okay, so if I had like the gas here, but this SLG stands for solid liquid gas for those who don't know. Okay, if you're going from the water vapor gas to liquid water, that would be exothermic because it's it's um, it's releasing energy when it's going to the left. I don't know how to explain it, but it's building bonds, and when you're building bonds, you always release energy. We'll take that later though. المهم, cooling water vapor, that's exo. Okay, and reacting NaOH with HCl, just memorize this one. It's exo. It's in the book, and honestly, I could see them giving you tomorrow. Uh, which of the following is exo, and you'd have to put these two. That's very probable. It could happen. Okay. Question 3. I think now they started Hess's law. Oh, still okay. Which are not properties of knowable gases? Okay, that's very easy. I'll go fast. You know, obviously highly reactive, and they don't decrease down the group. Yani. These are repeat many times. Okay, yeah, it's actually in the quiz. The change in heat is delta H. Okay, delta means change, and H means heat. So change in heat. That's what delta H means. Okay. This one you memorize it, but Hess's law states that the heat evolved or absorbed by a reaction is independent of the path followed and depends only on the initial and final products. So, for example, if you were to have, um, let me think, Na, okay, plus Cl uh, is NaCl, okay, and it releases, uh, it's exothermic, so delta H would be like مثلا negative 52 kilojoules. Okay, by the way, if it's negative, then it's exo, and if it's positive, then it's endo. Okay, because positive meaning that the product had more energy than the reactant, and that means you had to absorb some energy into the reactant to get more energy here. That's why it's when it's positive, it's endo. And obviously when it's negative, that means the product has less energy, so that means from here to here we released some energy, meaning it's exo. That's just I need to explain. But if you see them, they might come. What does it mean if delta H is negative? You put exo, and if it's positive, you put endo. Okay, المهم, okay, what Hess's law says, okay, that mean what he's saying is you can switch up this, you can switch up this reaction. You can do the complete opposite. You could do NaCl, break it down to Na plus Cl, and you'd still get delta H is 52 kilojoules. Okay, except now it's positive, obviously, because it's endothermic. But that's not my point, okay? My point is, no, you can reverse the reaction, switch it up, just do the opposite, okay, and nothing will change. You're allowed to do that, but the only thing that will change is the sign of the heat. Okay, Also, Hess's law states, this is yani, it's not really explained well in the law, but you can multiply any equation by any number. So this NaCl is the same as saying 2NaCl gets you 2Na plus 2Cl. Just like in math. You know, in math, when you have x plus y equals 6, you can multiply the whole equation by 2 and get 2x plus 2y equals 12. Okay? So, same thing here. In chemistry, you can multiply the equation by 2 and you get this. Okay, then what do you think? If we multiply the equation by 2, what's going to happen to the heat? Is it going to stay the same? Obviously not, right? Since we have more changes happening. So now it's going to be 52 times 2, which is 104 kilojoules. Okay, that's just explaining the law. Now, I think next question is when. Yeah, obviously. So it's independent of the path followed, so it doesn't really matter what's happening. The only thing that matters is the initial reactants and the final products. Okay. Question 6. I think this is where it starts. No. Okay, still it's easy. Okay. In general, when we're calculating delta H, okay, in general, how they give it to you is let's take the NaCl example, right? Let's take it again. Na plus Cl equals NaCl. Let's take this example. Let's say I had 30 kilojoules in Na, 20 kilojoules in Cl, okay? And in NaCl I had 100 kilojoules, okay? What would delta H be? Well, these numbers are wrong, but let's say 10 kilojoules, okay? What would delta H be? Always delta H would be products minus reactants, okay? And how they write it in the book is sigma, I think, products minus sigma reactants, okay? Basically meaning just add these up, and subtract. So in this case it would be 10 minus 30 plus 20, okay? And it would be negative 40. That's delta H. So the thing is, what was I going to say? This is the general way of calculating delta H. But sometimes they're going to do like here. They're not going to give you the energy, they're going to give you bond energy. Bond energy, you do the opposite, okay? For bond energy, you do sigma reactants minus sigma products, okay? For bond energy, you subtract what's here by what's here. But the general term, when you have a equation, you subtract the final minus initial, okay? But here, you subtract the initial by the final. That's just how it goes. I don't know why, but I just chose to memorize it. ما بدي أتعب حالي. المهم, so in this case, I think some people find it really straightforward. So we're gonna have to add up the energy here and then subtract it by the energy here. So let's see. Here we have CH, 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 CH. So we have 4 CH bonds, right? And then here we have a Cl bond, right? So 1, no, actually we're not done, sorry. We have 4 CH bonds, right? And then in the middle we have a CC bond, right? A CC bond. So and then we have 1 CC bond. Okay, then over here we have a Cl bond. So 1 Cl, Cl. Okay, pay attention to all bonds. It would really be annoying if you forgot to count a bond just because you didn't see it, and that would be a very silly mistake. Okay, so we have to now add these up. So 4 CH bonds, you just look at the table. CH is 413, so 4 times 413. And then 1 CC, again, just go to the table, it's 602, so 1 times 602. And then 1 CL, you just go 1 times 240. And then you add these up, okay? I don't have a calculator, or actually I do. 4 times 413 plus 602 plus 240. Okay, 2494. So 2494. Now we got the initial, yeah? So we have to subtract it. We have to subtract it by the final. Okay, now let's look at the final. The product side, we have Cl, Cl. CCl, CCl. So we have 2 CCls, right? Then we have CH, 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 CH. 4 CH bonds, right? So let's do it. It's going to be 2 times CCl would be here, 327. And then CH would be 413. 4 times 413. And let's calculate it. It would be 2 times 327 plus 4 times 413, and you get 2306, and there's obviously something I did wrong. Hold up. Okay, yeah. I forgot to add uh, the CC bond. See, and no, sometimes you can forget, huh? Please pay attention in the exam, don't do this. Uh, so the CC bond would be 1 times CC 346. So 1 times 346, yeah, over here at CC. Now let's just add the 346 plus 413 plus 2 times 327. Yeah, I definitely did something wrong. Hold up. Yeah. I multiplied wrong. 2 times 327 plus 4 times 413 plus 1 times 346, 2652. And then we said for bonds, you subtract the initial minus the final. So it would be 2494 minus 2652. 2494 minus 2652. And yeah, 2494 minus 2652. You get minus 158. And they said 4 significant figures, so put the point 0. Okay, question 7. I think now is when it gets hard. Okay. This is the direct application of Hess's law. Okay, Hess's law, the application or the way they use it is it's pretty annoying, but I'm gonna try and be as straightforward as possible. Is this the correct answer? I'm gonna try and be as straightforward as possible. Okay. Remember with Hess's law, if you were to reverse the reaction, the sign of the energy changes. If you were to divide by 2, then you divide the energy by 2. Okay? Whatever you do to the reaction happens to the energy. Okay, so how they would do this for Hess's law, they tell you, they'd say, they'd yap a bit, they'd give you two equations, okay, and then they give you a final equation, okay? So they'd ask you to calculate the enthalpy change meaning heat change, okay, of the final equation, okay? So what you would do, okay, and this is the way I like to do it, okay? I would write down my final equation, NO2 plus half O2, okay, to get NO2. I'd write it down. Okay, then I'd look at what I have here. Okay, I'm gonna separate my final equation and I'm gonna leave some space down here. I'm gonna use this area to work. Okay, don't get mixed up. Don't mix up your working area with the equation you have written. Okay, this is what our final equation should look like. Okay, and it's given here. So for that reason, I'm gonna have my working area separated from my from the answer I'm trying to get, if you get what I mean. So this is my working area down here. Let's see. 203 to get 302, and then NO plus O3 to get NO2 plus O2. The way I do it is, I take a look. With oxygen, I always leave it to the end, okay? Because oxygen is always a pain in the ass, okay? When solving with oxygen, it's very annoying to solve at the start, so I always keep it to the end. Please take my advice. Don't solve with oxygen at the start. So the first thing I look at is the other elements, okay? NO and NO2. Let's take a look at NO first, okay? So I have to somehow manipulate, or I have to change one of these reactions so that I have NO at the start. Because you see, NO here is at the start. It's not at the end, it's at the start. Let's take a look. In the first reaction, I don't have NO at all. So obviously, I'm not going to use the first reaction. And in the second reaction, I do have NO at the start. So what do? This is the reaction I want. Step 1 is to identify which reaction you want. And we found it. This one over here. You ask yourself, do I have to switch it? Do you? I mean, here NO's at the start, and here NO's at the start. So no, we don't have to switch it. Then you ask yourself, are the coefficients equal? NO and NO? Yes, they are. Okay? So that means you don't change anything. You just rewrite it as it is. NO plus O3 to produce NO2 plus O2. Okay? That is how you work. Okay? And this method is very important. You have to memorize it. Okay? You have to use this method. What is this negative 122? It's just the energy of that reaction. Okay, what's next is NO2. But didn't we just take NO2 from this equation? This equation actually gave us both the NO and the NO2. You see? So we're getting there, right? Now we have to work with oxygen. And as I told you, oxygen is a special case, okay? It's very important to know what you're doing with oxygen, because with oxygen you have to focus with the numbers. With oxygen, you don't copy the same number, Okay, not necessarily. Sometimes you do, sometimes you don't. Here's what you do. You look at the reaction you have, okay? You look at the reaction you have. I have أول شيء I want to see which one has oxygen in the reactant side, right? It's before the arrow, so it's in the reactant side. Obviously, it's this one, O2, but here O2 is in the product side. So the first step is, do we have to flip it? You ask yourself, do you have to flip it? In this case, yes, we do. 3O2 to produce 2O3. So we flipped it. What happens to the energy when you flip it? It becomes positive, right? So positive 427. Okay, now Walid, do I have to divide by 3 because it's the same coefficient over here? Okay, here's what I would do. Since you have it over 2 over here, okay, that means this one also here you should have it over 2. That's the thing with oxygen. It doesn't mean if you have 1 over 2 here, that means this should become 1 over 2. No, 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 no. With oxygen, it's a special case. You can't have make it have the same coefficient. Okay, so this is over 2. This should be over 2. Okay, that won't always work because I'm not going to teach you something that's wrong. Okay, that won't always work. What you have to do here, oxygen is 1. Okay, and it's in the product side, so you're subtracting it. Okay, something, I don't know what, something subtracted by 1 should give me 1 over 2 as my final answer. Okay, I know this might sound confusing, but please try to bear with me. I have to find out what is my coefficient for oxygen, and for oxygen you just have to see something subtracted by this gets me my final equation. Okay, here we have 1, here we have 1 over 2. Okay, box minus 1 equals 1 over 2. Obviously just take 1 to the other side and you get 3 over 2, because 1 over 2 plus 1 is 3 over 2. Okay, and then now you know that your coefficient has to be 3 over 2. In this case it's 3, so what do? I just divide the whole reaction by 2, right? Yes, just doing over 2 from the start would work, but that won't always work. Okay, if you want, test your luck in the exam. If you're not bothered to do all this, test your luck in the exam, do put over 2. I don't know if it will work, but until you just test your luck. Okay, المهم we put it over 2, so this 3, it becomes 3 over 2O2 to produce. Now 2 over 2, they cancel 2 with 2, so it just becomes O3, and my delta H is now 427 divided by 2, which is, if I'm not wrong, 213.5. It should be 213.5. Okay, what do I do now? Okay, with Hess's law. So we identified everything, we did the reactions, we rewrote them in a way where they can cancel each other out. What do I mean by cancel each other out? This, we can subtract. Okay, it's like math. NO, is there anything for me to subtract it? No, I don't, so I just take it down. O3, is there anything for me to subtract? You'll always look at the opposite side. If it's the same side, you add. If it's opposite side, you subtract. Okay, like in math. So O3 on this side, is there an O3 on the opposite side? Yes. So you can cancel. You subtract them with each other. 1 O3 minus 1 O3. Okay. Now NO2. Is there any NO2 down here? No. Right? But now we're after. We have to draw the arrow because NO2 is after the arrow. So we put NO2 over here. Okay. So cancel NO2. How about O2? Okay, we have O2 here and we have 3 over 2 O2 here, right? So they are on opposite sides and we subtract them. Okay, you always subtract the left minus the right. Okay, please don't ever do right minus left. Okay, so 3 over 2 minus 1 O2, right? It's 1 O2, and you get 1 over 2. 3 over 2 minus 1, you get, how do I write? 3 over 2 O2 minus 1 O2 gets me 1 over 2 O2. Okay, there you go. This answer here, we put it on the left side. Okay, and you see, now the reaction they told me to find, I found that reaction. But now كلها على الفاضي. All they're asking for is the heat change. Okay, what do I do with the heat change? I just add them. Negative 122 plus 213.5, and you get 91.5. Okay, that's all you have to do. It's just the heat change part. Sure, it might be a bit tricky working with oxygen, and there are easier ones. This Salah is one of the harder ones. Like, look at question, I think, was it? There was another one, somewhere. Okay, I think it's, if it's not the next one, I think it should be the next one. Yeah, like this one here. This one's way easier. Okay, So let's see here. Again, we have our final reaction. Okay, what do? We write down our final reaction, COO plus half O2 to produce CO2. Okay, what's the first thing I told you to find in your working area? You leave your oxygen for last. Let's see, CO. CO, here it's in the reactants, right? I want it so I want it so my CO is in the reactants. Here I have CO, but it's in the products. So do you ask yourself, do I have to flip it? In this case, since it's in the products and we want it to be in the reactants, you have to flip it. So let's flip this equation. It's going to become CO to produce C plus half O2. And since we flipped it, what happens to the sign? It becomes plus 110. Okay, so let's write it down here. CO to produce C plus half O2 plus 110. That's the delta H. Okay, delta H is plus 110. Okay, how about now the CO2? I want the CO2 to be in the product. In this case, CO2 is in the product, so you ask yourself, do I have to flip it? No, I don't. And also, by the way, here, it was the same coefficient, 1 and 1, so I didn't have to multiply by anything, huh? So CO2 here, we have to flip it because we want it in the products. And again, same coefficient, so no need to multiply. So let's flip it. It's already in the products, so no need to flip it. Okay, here it's in the product, and here it's in the product, so no need to flip it. We just write it down as it is. C plus O2 to produce CO2. And since we didn't flip it, we didn't multiply, the heat stays the same. Negative delta H equals negative 393 kilojoules. Okay, now we start the final step. It's combining like terms. Okay, C cancels with C, right? CO, is there anything for me to subtract CO with? No, not CO2. Can you subtract X with X squared in math? Of course you can't, right? So I can't subtract C with CO, so I just take it down. Okay, now this CO2 also, I can't subtract it with anything, so let's just take it down, right? But we have one O2 and we have half O2. Okay, here, sure, I didn't, do it separately for oxygen because oxygen didn't have its separate reaction. Okay, so the oxygen kind of came in with the other CO and CO2s. Okay, it kind of it came in automatically. We didn't really have to write anything for oxygen. It didn't have its individual reaction, as opposed to question 7 here. Okay, it was harder because oxygen had its own reaction. In this case, oxygen was with another element, so it's way easier when it's like that. Okay, but that's why I didn't really have to multiply oxygen by anything. Here I just kept it as it is. So المهم, we have to subtract it, right? Always the left one minus the right one. And this is 1O2. 1O2 minus half O2 is going to be half O2. Okay? Is my initial reaction the same as the final reaction they wanted me to find? Yes, it is, right? So what do I do to the energies now that I know they're the same? I do 110 minus 393, and I get minus 283. Okay, sure, it might be a bit confusing, this question. It might be a bit confusing, but please just bear with me. It's not. Once you practice, you'll get the hang of it. Okay, rewrite. This is very easy. Rewrite the equation expressing the coefficients as the smallest whole numbers. Okay, it's super easy. Okay, the only tricky part might be the energy part. Okay, they want it as whole numbers, and obviously it's not in whole numbers. We have the half. Okay, how would you get rid of the half? You would multiply everything by 2, right? You have to multiply it by 2 to get rid of to cancel out the 2, the over 2. And if you can't just multiply it by one thing, you have to multiply by the whole equation, right? So it'll become 2c plus, and they said state symbols, huh? Don't forget state symbols. So put solid plus O2. You don't write 1O2, you just write O2, which is gas, to produce 2CO, right? Again, gas. Okay, now the energy part. They said minus 110 kilojoules per mole of CO. Okay, here we had 1 mole and it was minus 110. Now we have 2 moles of CO. So what do you think is going to happen? Just multiply this by 2 also. So it's going to become negative 220. Okay, طب Walid, how would I write negative 220 as my energy? Where would you put it? Okay, see, here's the thing. What did we say would happen? What did we say it meant when the energy was negative? When energy is negative, we said it meant that the reaction was exothermic, right? It was exothermic. Exothermic meaning it releases energy, right? So where would I put it? At the start or at the end if it releases the energy? Obviously at the end. So I would put plus 220 kilojoules. One way I like to look at chemical reactions, if anything is on the left, it's positive, and if anything's on the right, it's counted as negative. Okay, even though it is plus 220, but since it's on the right side and I count it as negative, that's how I look at it in my head. So you just copy that, copy all of this, put it in here, and you get it correct. Question 10, I think they say write the reverse. Yeah, okay, they gave you this reaction, very easy. They say write the reverse reaction. Literally, all you have to do is just flip it. That's it, okay? Just flip the reaction. I'm not gonna bother, okay? Then they say what happens to the energy? You know, what's the energy now of the reverse? Akid, since we flipped it, all that changed is the sign of the reverse. Here it was negative, onwards here positive, okay? Question 11. Okay, nitrogen monoxide gas NO, okay, reacts with oxygen gas O2 to produce NO2, releasing 56 kilojoules per mole of nitrogen monoxide. Okay, they're saying write the equation. This is very easy. Okay, I'm gonna show you the steps I used to solve. أول شيء we have to write down our reaction, right? NO. Forget inside state symbols. Forget the state symbols for now. Okay, we'll put the state symbols later. But our general equation: NO plus O2 to produce NO2. The first thing you look at is my equation balanced? And obviously here it isn't because I have 3 here and I have 2 here for oxygen. So what would I do? I would obviously multiply by 2 to make this 4. And now how would I make this 4? I would just multiply by 2. Now, is it balanced? Yes, it is. And then you look at your energy. Okay, خلصنا خلاص, we got our reaction. You look at your energy. They said 56 kilojoules per mole of nitrogen monoxide. Nitrogen monoxide is NO. Okay, they said it also. Nitrogen monoxide is NO. How many NOs do I have now? I have 2. So what would you do to this? We'd multiply it by 2 and it becomes 112 kilojoules. Okay, طب Walid, do we put it at the start or at the end? They're saying releasing. Releasing. That means exo, right? And if it's being released, that means obviously at the end. And Akid, you guys write the state symbol. They said gas, gas, gas. I'm not gonna bother myself and write them, but it's written in the answer here, okay? Question 12. Okay, these are old questions, but I'll go over them. Okay, so they gave us a reaction. They're saying 108 kilos of aluminium is reacted with excess oxygen to produce aluminium oxide. Just because they give you the word excess, don't think it's a limiting excess exercise. A limiting excess exercise can only be identified when they give you 2 values. Okay, here they only gave us one number, and that's 108. So part A, they're saying find the number of moles of aluminium. So you just do N equals M over M. Okay, and the mass of aluminium is 108,000 because it's in kilograms. And you guys know in chemistry, we work with grams, not kilograms. Okay, maybe physics might be something else, but here it's always grams. 108,000 divided by the molar mass of aluminium, which is given 27, and you get 4,000. Okay, then they say calculate the number of moles of oxygen. Okay, very easy, right? We have the aluminium. How can we find the oxygen? Just from the reaction. Plus 3O2 to produce 2Al2O3. Blah, blah, blah. Okay, so in my reaction, I have 4 aluminium. And in my reaction, we can use RR and GR. If you guys know what that is. In Sharjah, that's how they teach us. Okay, for 4Al, okay, in the reaction. And in oxygen, it's 3 in the reaction. Okay, how much do I have given for aluminium? 4,000, right? But now I want to know how much oxygen I have, okay? So it's X, obviously. Cross multiply, okay? And you get 3,000. Okay, then they say calculate, I think, the mass of oxygen. Yeah, very easy. You know, if you have the moles of something and the molar mass of it, then you can calculate the mass of it, okay? Let me go up, okay? So you just use N equals M over M, right? The moles of oxygen we said is 3,000. Okay, 3,000 equals the mass of oxygen, which is, we don't know, we're trying to find it here, over the molar mass of oxygen. It is 16, but if at this stage you put the molar mass of oxygen gas is 16, then you should please go back to grade 9. The molar mass of oxygen is always 32 if it's a gas, okay? And aslan is given O2. Please do not put 16. Cross multiply and you get 96,000. Okay, 96,000 grams. بس هن قايلين kilograms. They're saying put it in kilograms. So obviously 96,000 grams is 96 kg. And أكيد they're saying for SF, so you put 0, 0 at the end. Okay, 0.00. Question 13. I think these are the easy ones. Ah, uh, okay, I'm gonna go through this a bit quicker. Okay, because this is probably the 9th time I solve one of these in my videos. المهم, heavier gas. Obviously, the heavier gas would be the lower rate of diffusion because it's slower, so it has a lower rate. And in this case, it's gas X. How would you find the molecular mass? It would be V1 over V2 equals radical M2 over M1. And V1, I would always put the lighter one on top, so 0.87 over 0.63 equals radical M2. Okay, M2 0.63, it would be gas X, right? Over M1, which is the one for 0.87, which is hydrogen chloride, which is 36.5 because hydrogen is 1 and Cl is 35.5. You just add them, it's given. Okay, 36.5. How would you solve this? You have to square both sides, okay, and you're gonna get, I don't have, I think I have a calculator over here. No, the delete, oh, yeah, scientific calculator. Okay, so 0.87 over. Okay, خلاص, I don't have a calculator beside me. Let me. Okay, I put it into a Google calculator. Uh, yeah, I think it's 840 over 441. Okay, so 840 over 441 equals x over 36.5. Okay, and I think you just do times 36.5. So wait, hold up. This cannot, hold up. Okay, and I do times 36.5. I get, yeah, 69.6. Okay, so yeah, 69.6. So let me bring the pen back down. So if you multiply by 36.5 on the other side, you get 69.6. Okay, part C or B, obviously the lighter gas would be the greatest rate of diffusion, and then the heaviest gas would have the lowest rate of diffusion. CO2 is 44, HCl 36.5, H2 is 18. So since it's the lightest, it has the highest rate of diffusion. Okay, last one. Which one? What is the phenomena? Obviously diffusion. Which one's the lighter gas? Since gas A reached to gas B's side, that means gas A has a faster speed. Okay, I'm not gonna explain this anymore. Okay, concentration of ions, it's not limiting excess, okay, because they didn't say precipitation happened. So all you have to do is just write down the dissociation reaction for each one. Okay, this was from term 2. So for concentration of ions, remember the first step is always to write the dissociation reaction, and then for concentration you see equals N over V total. So let's write them down together. Step 1 is write the dissociation reaction. Write the dissociation. Okay, so you have two compounds. You have Na2SO4 and you have ZnCl2. So let's write the dissociation for each one. Na2SO4 to produce Na plus SO4. And obviously we have to balance it. So you have 2 Na here, so you have to put 2 here. Okay. Then for ZnCl2, dissociated ZnCl2. Okay, sure, let's put plus 2 minus the charge. Okay, ZnCl2 produces Zn and Cl. Okay, remember Cl can never be Cl2 when it's alone. Yeah, when you're talking about ions, you don't put Cl2, you just put Cl. Okay, because we're talking about ions. So if I said chlorine gas, you put Cl2. المهم, to balance it, you have 2 Cl's here, so you have to put 2 here. Okay, and also Zn plus 2 plus here minus. Okay, the charges don't really matter. They said we have 0.1 mole of sodium sulfate. So here I have 0.1 mole. Na would be double that, right? So 0.2 because Na is 2 Na. Okay, and SO4 has a coefficient of 1, so it doesn't change, it stays 0.1. Okay, then ZnCl2, they said 0.2 moles. Okay, so you put 0.2, then Zn stays 0.2 because same coefficient. But here Cl has a coefficient of 2, so you just multiply by 2, comes 0.4. Okay, now we have the moles for everything. Okay, so how can I find the concentration? Remember, C equals N over V total. Okay, I'm not going to write total. So let's start with sodium. Okay, before solving, find V total. The total volume would be the two volumes they gave: 50 cm cube plus 150 cm cube. 50 plus 150, which is 200. Okay, and this is in cm cube, right? But we need to make it in dm cube. Remember, volume has to be always in dm cube, and to that you divide by 1000, so this becomes 0.2 dm cube. So our V total is 0.2. Because why am I doing this at the start? Because you need it for every single one. Okay, so let's start with sodium. The concentration of sodium will be the moles of sodium, which is 0.2 over the volume 0.2, and you get 1. Okay, then for SO4 2 minus would be the moles of SO4, which is 0.1, over the total volume, which we said was 0.2, and you get 0.5. Obviously, two significant figures for everything, huh? Then Zn2 plus, it's 0.2 over total volume 0.2, and you get 1. Then Cl minus, the moles of Cl minus 0.4 over the total volume, which was 0.2, and you get 2.0. Okay, again, two significant figures. I think that's it. Yeah, that's it. Thank you so much for watching. I know this one was a bit trickier than the usual Chem AMSs, but good luck. Thank you for watching.